Welcome back to the workshop. So there's been a small delay while I waited for some laser cutting for the tops of the tanks, but that's in now, so let's see if we can finish them off. And here is that laser cutting. So we've got a whole bunch of 6mm aluminium plates, same material as the rest of the tanks are made out of. We've got a hole and mounting holes for the fuel sender unit, fuel level sender unit, and then a nice big opening with a corresponding top plate. So this top plate will have the fuel pump mounted to it, it will have the inlet and outlet ports coming out of it, and it will also have the fuel filler neck welded in. So I wanted to put the fuel filler neck on this removable plate because that means I can mount the tanks into the car, and then later on, when we're fine-tuning exactly where the bodywork sits, I can come back and position the fuel filler neck in exactly the right spot, take it over, weld it on the bench, and don't have to disturb the tanks. That's the first part. The second part's mounting the tanks to the car. So that's what these 8 holes are for. Like I said, I don't like the idea of having aluminium tags welded to the tank to mount it to the body. The plan is to drill and tap all these holes for M6 threads. So we'll have nice M6 studs sticking out of the top of the tank that we can then bolt probably a steel bracket going back to the chassis rail. Obviously, having M6 tapped holes going straight into the fuel tank is not ideal without some sort of sealing arrangement. So the idea is to use a bunch of these hydraulic, I think, Doherty washers, sometimes they're called, sealing washers. I've used these before, these are really good. This is an M8 one, I'm still waiting on the M6 ones. But the idea is to throw one of those on there, and then once the tank's all welded up, I can get inside and screw these little button head screws from the inside up. They'll seal from the fuel and give us a whole bunch of nice, strong studs to mount all the hardware to. That's the plan. So the first thing to do is drill out and tap about 50 M6 holes over to the mill. So let's thread some holes. Like I said, 50 odd or just under 50 holes to do. Not enough safety gear in the world to hand tap that many holes, so I'm going to attempt to machine tap them. That's a little bit difficult in this mill because I don't have a tapping head for it, and it doesn't have a reverse switch either. So we will see how we go. Likelihood of snapping a tap is high. First thing is center the hole with the drill. We'll clamp it down. Try again. Swap out our drill. For the tap. Give ourselves every opportunity of getting this right. Bit of cutting fluid. Okay, let's do this. Unfortunately, that is the slowest this mill will go as well, so going to have to be pretty quick on the off button. One tapped hole. Don't know what I was worried about. This is one of those jobs that goes well until it doesn't. Alright, let's repeat that 50 more times. So amazingly, we got through that endeavour without breaking a single tap. One more feature to add to these plates before we look at mounting them to the tanks. And if you look very closely at this area here, you can see a hell of a lot of surplus weight that isn't doing much for us. Unfortunately, speed holes aren't going to be much good in this situation, so it's back to the mill. Oh yeah, that feels way more exactly the same weight as it was before. Anyway, those top plates are done. Time to move on to the little cover plates. These are a little bit massy as well, and I'd like to thin down the area that I'm going to weld the filler neck to, because 6mm plate is a little bit aggressive to weld to. Because I want to make it look like a race car fuel tank and not just a tank, I'd like to machine a nice little oval pocket inside these top plates. But to do that, I need to introduce you to the latest member of the workshop. Say hello to my brand new rotary table. I've wanted one of these for ages. So the plan is to clamp our cover plate onto the table, and then we can machine out our circular pockets at each end. As you can see, the cover plate is almost bigger than the table itself, and the T-slots only just hang out each end. Might be able to jerry-rig some nuts and clamps to hold it down, but I thought I would make this adapter plate. It's got some countersink holes for some M8s that will screw into the T-slots, and then I've got these 4 threaded holes which hopefully will line up with 4 of the holes in the cover plate. This way, once I've set up that adapter plate, it's pretty easy to just bolt one end on, machine it, spin it around, bolt the next one on, and I don't have to muck around with too much setup work. Ignore these 3 holes. I'm going to use this as an adapter plate for a small chuck that I've got lying around. So I've got an attachment to the rotary table. So the first job is to center the rotary table to the spindle. And as you can see, the rotary table is perfectly centered. Only kidding, that totally doesn't work. To center the rotary table, we've got the indicator in the spindle, and we need to spin the spindle around until we read 0 movement, or close as we can get. And we're a little bit off at the moment. Okay, that's a bit hard to film, but I'll see what I can do. So we've got 0 there and 0 there. So I will 0 out the DRO. No, that's turning it off. 0 the DRO. And now we can bolt the top plate. So now I just need to center our top plate to the rotary table. I'll disengage the worm drive. So now we should be able to spin the table around. And it's already very close. way. Re-engage the worm. Have a look how we're sitting. All right, we're getting dangerously close to actually being able to do some machining. So here we go, we've got our 10mm carbide end mill. I've got the air hose hooked up for some chip evacuation, and I have remembered to close all the drawers in my toolbox this time. We want to end up with a pocket with a radius of 49mm. That's the 10mm end mill, so half of that is 5. So we want to move the table eventually 44mm out this way to give us that full 49mm radius. Let's see how we go. And then they are all completed. The finish on the top surface was really bad. The tool marks were quite deep, so I hit it with some sandpaper and then hit it in the sandblasting cabinet. But I kind of like that finish. I think it'll be a nice contrast to the top plates. Once I've welded in the filler neck tubes, I'll do a better job of sandblasting them. Before we move on, we should probably talk about this little feature here. This could be a little marking to differentiate the left and the right caps. It could be a tiny little finger hole to help you pick up the cover. Or it could be that I forgot to deduct half of the end mill diameter on the DRO. Yeah, not happy, but I have to live with that and move on. And move on to the fuel pump mounting. So the fuel pumps have arrived and I ordered the wrong one. This is the same pump that I was planning on using, but it's got an integrated filter, which means we need to modify our little foot to sink the pump down even further, but that's no big deal. Got this little bit of LE tube. I'll clean that up on the lathe and then we'll split it in half, and that will create 2 little semicircles that we can use to clamp the pump to. I'll probably machine a groove in there and just run a hose clamp around the whole lot. That'll sit on there, something like that, and that'll give a nice face for the mounting tube to come up to the top plate. Unfortunately, it can't be a straight tube such as that, so we'll have to look at bending that later. Back to the lathe for a second, I think. Not too bad at all. Resisting the temptation to pull the fuel pump out of its little bag, but trying to reduce the filth intake. So on the other fuel pump foot, I've cable tied the soon to be support bar. Let's throw that in the tank and in its current form see how far off the position in the top plate that we need. So there's the fuel pump foot sitting in its desired location. And you can see the pole is pretty much touching the back of the tank there, so that gives us a good datum to measure off. And that little black mark indicates the widest part of the opening in the top of the fuel tank. That was probably a little bit complicated. Let me try and explain. So currently the tube is sitting here in relation to the top of the tank. I think the best spot for that tube to mount to the cover plate is here. That gives us plenty of room for the inlet and outlet ports, some room for electrical terminals for the fuel pump, and plenty of space to move the filler neck around. So it should just be a simple matter of bending that tube with a kink in it to make up that distance. I do want to slightly complicate the situation a little bit further. I want to make this leg removable, and I just want a single center bolt going into a boss that I'm going to weld into that tube. So not only do we need to move the position across, we also need to get the angle as perpendicular to the plate as possible. Let's see how we go. So I measured the angle between the top of the fuel tank and the tube as it sits, and that's 96 degrees. So we're 6 degrees off perpendicular. I've decided to make life a bit easier. I'm going to try at least to put 6 degrees of bend in the tube first, then we'll put it back on the foot and remeasure the location, and then try and do 2 bends to translate it across. The robot uprising is upon us. So after I did that first bend, everything was lining up pretty well, so rather than overcomplicate things too much, I just eyeballed the second one and managed to get away with it on both the support tubes. They've lined up very nicely with where I want them, and they're pretty much perpendicular to the top plate. I've turned up these little fittings to go on the top. We've got an M8 thread in the end of them, and rather than make them a size fit, I machined this rib for her pleasure, around the edge, and that allows quite a bit of angular misalignment. So when the time comes, I can weld that in to the tube at a slight angle if required, just to get everything to line up exactly the way we want it. So the idea is to drill a hole in our top plate, and then our fuel pump mount will bolt on something like that. And that's the last thing I want to do before we weld the tops onto the tanks. Only one thing for it. Let's drill a couple of holes. I've given the tanks a good clean on the inside. Can't put it off any longer. So we've finally got the tops welded onto the tank. I've also welded on the little bung inside the tube and bolted it through the top plate. And I'm pleased to say that not only can you fit the pump into the tank, everything lines up as expected, I hope. Okay. Now we can finally look at mounting the tanks to the car. I've already got the tank sitting on some of this rubber sheet for a bit of vibration damping, so it's already at its final resting height. I spent a long time trying to work out a way to strap the tanks in, pretty much because I wanted to reuse those jigs I'd made up for the muffler straps, but due to the sort of curved nature of all the sides, straps weren't really an option. I've settled on utilising the 6mm top plate to mount the tank off, and hence why there's these 8 additional threaded holes. The tanks are pretty well located just by where they're sitting, so there's not too many degrees of freedom that the right angle brackets need to account for. They've got to stop the tank bouncing up. Their main job is the lateral location, and they've also got to stop a little bit of twisting, but not a huge amount of directions they've got to constrain, so a couple of little 90-degree brackets should do the job nicely. I guess you could argue that I'm still using a welded tab if you want to say that the top of the tank is a welded tab, but there's a huge amount of surface area there, thick material. I'm not too worried about it. So back to the fab bench and make up some nice brackets. So that was a lot of bloody work, but the tanks are pretty much done. Very happy with the mounting. With that last bracket snugged up, the tanks are super rigid. They are not going anywhere. That last little bracket has got a very deep dished hole milled into it where that sort of large grub screw fits in, and it's captive in there. So even if the bolt did come loose, that bracket couldn't jump out. But I don't think that's an issue anyway. Tanks themselves are finished. Still got a little bit more work to do on these cover plates, but that's drilling holes and adding inlet and outlet ports and electrical connections and stuff like that. Not a big deal. So I think that'll have to do for this episode. Thanks for watching. Cheers.